You know, in ClueCon tradition, some of our favorite events are the roundtables. We get a group of great experts together and put them up on stage for the benefit of our audience. And today we have our Webrtc roundtable. Some of the most exciting technology in VoIP and some of the best experts are here with us today. Moderating the panel this year is Chad Hart. He's got with him up on stage Anthony Minicelli, James Cad from Microsoft, Jonathan Rosenberg from Five9, and Lorenzo Miniero from Miteco. Chad, what do you have for us today?
Great. Thanks, Travis. So I have a lot of questions for the panelists, and hopefully my questions are shared with the audience. We're going to spend about roughly 5 minutes on each of these, and there's plenty of time for audience questions. We're here for about an hour. I just ask if you see your question, if it's in this list, hold it, and then when we ask that question, if I don't ask enough or you want more, just raise your hand and we'll do follow-up, right? So we can take breaks in between or in between my questions and ask more audience questions. But again, if you see your question as a subset of this topic, just raise your hand and ask, and we can go a little bit more. So I've asked each of our panelists to I've given them kind of two questions actually to spend a little more time on, then the other panelists can chime in, and we'll go back and forth. So why don't we get started, and I'll actually go and sit down. So there's been there's always a lot of updates with browsers, and browsers are one of the biggest pains in the butt with WebRTC because they keep changing and they don't necessarily tell you before they change things. Maybe starting with you, Anthony, can you tell us a little bit, I guess bring us up to speed of what's new with the browsers, what's changed, and I guess what are some of the things that you've had to do with the SignalWire FreeSwitch?
So the browser has actually been pretty kind to us in the last year. One of the newer things I've noticed is there's some things with rather than dropping packets when you send them, or you don't send enough, they kind of delay and try and twiddle-bug their way back to real time. So like if they get a burst, that burst loss isn't gobbled up anymore. It kind of just speeds up until it gets back to where it belongs. And I think that the one that I'm pretty excited about is for simulcasts, there's a really long way to go on that still, but they finally adopted this unified plan thing, which is going to, 2015, we're supposed to get that, and it kind of is there now. Enough of it's there.
Can you just explain for the audience, I guess, what was that going to mean for them?
So they completely changed the way that the STP negotiation works, so that everything will be broken. But like once we get past that, we should
sounds
have
fun.
Yeah, right.
For video switching.
Yeah, and this, I guess, specific Chrome was Google was the last holdout.
Yeah, I think one of the problems is that sometimes we future-proof too much. SIP never did anything other than make phone calls, yet it had all this great potential that it could have set up all kinds of other stuff that wasn't phone calls. But with WebRTC, kind of running into don't want to make that mistake again, so it's kind of going the other way. And we started to imagine why are we setting up a call that only has one video stream in it or one audio stream, or why can't I just say 10 of them at once? And they're still trying to use the SDP, and then some people hate that. So the compromise I've seen now is this: with simulcast, you can budget your bandwidth. So say I was going to send you a stream, and it had a certain amount of resources available. The Chrome doesn't want you to do math and stuff because they think it's too hard for an end user. So you just kind of give it a few parameters, and they'll just do it for you. Well, you've given me permission to use 2 megabits, and you want a frame rate of whatever, and 30 frames or whatever. If you turn on simulcast now, it'll do, it'll split it. So you can say, I want 3 versions of that, and it'll let you, they just added a thing, it's kind of already been there, but it was kind of unusable because it was hard-coded to a certain thing. But now you can pick the divisor of how much of your resources you want to split amongst how many different things you want, which is super important because now you can just say, if you wanted to set up thumbnails in full video, so you can sacrifice 20% of your resources to making another thumbnail of the same thing you're already sending. So then when you go up to the server that forwards packets, you send everybody the thumbnails except for the one guy who's talking. Because one of the dilemmas in a SFU is if you have a lot of high quality video streams, then the poor guy on the other end is going to get 8 megabits because everybody's sending up 2 each, and you have a 4-person conversation. So you want to figure out how do you just send littler versions of them. And if you don't do the MCU version where you're only sending one stream, that's the next best thing. So simulcast is kind of step one. I think there's a lot to go with it because we have the whole SVC thing. And once VP9 is more usable, we'll be able to cut up the resources even better. You can send one stream that kind of, you don't have to send 2, you send one that you can actually decide to peel back some of it. And I mean, that's sort of in progress now, but it's also a little hard to use in real life because there's some scientific.
And we will talk. I actually want to talk about video codecs. I'll add VP9 in with the last question on AV1 too.
So yeah, that's kind of like, I think the beginning of that is starting to happen. It's only one way. That's another problem. Like the answer can have 20 video streams at once now, which is cool. And so you have one peer connection, and you're sending all those video streams, and you can tell them apart, and you can put them in their own canvas. And you can't offer them yet. Like the real idea would be like, I have 3 cameras and a screen share and whatever I want to do, and I can say all that right away, and then I'll offer all those, and then it's not equal. So the browser and the server side are still kind of different, and then I think they're converging towards the same. So it's like the beginning of that is sort of laid now. So it's like a little closer to really being able to make products out of it, and that's kind of something we deal with a lot because one of our goals is to make it usable right away and to protect you from that weird changing stuff and see if we can like absorb it. As the things mature, then we'll just push it out to you with the same kind of code.
I'm curious, Jonathan, I mean, at 5.9, you're probably mostly PSD audio to agent sort of thing. So simulcasts matter to you? I mean, is that...
No, simulcast, I mean, I did this in my prior job. So as a CTO for WebEx and Cisco collaboration, and we spent a lot of time on this thing. It's mostly for video conferencing. That's its main use case is, as Anthony said, like, you want to build a cheap switch for video. You don't want to have to decode and recode like we do for audio.
So I guess your case, unified plan doesn't really make a whole lot of...
No.
A whole lot
video
of
conferencing.
I guess another topic on browsers, I'll call on James next. Now, I should comment that James works for Microsoft, but he's not part of Edge team. He does Universal Windows Platform. He's going to talk a little bit of that next. But yeah, another big move is Edge going to Chromium. Anything you care to say as the designated Microsoft expert on stage on that?
Well, I think that's a good point that I don't work for Edge. That said, I do work with them. We talk pretty often. I think what was interesting to me when they started to consider using Chromium was the difference in use cases between browser and native apps. So we've done a lot of work in the native stack to enable applications to do things like read raw audio and video, perform ML against that, even inject video into a peer connection so you could have a synthetic video feed that's being relayed to your peer. And when we started talking about Edge moving to Chromium, the question came up, well, hey, do we use this UWP stack that we've already invested in for years, or do we just pull right from Chrome? And what it turned out was that people don't want to do those things, or at least not as often, in the browser. So it made a lot more sense for Edge to just stick with Chrome. We've seen a lot of bugs just go away from switching to that stack. So hopefully it's been a net positive experience, and definitely would like to hear your feedback if anybody has it for Edge.
Okay. Maybe Lorenzo will give you a chance to speak too, because we didn't talk about Apple Safari at all. Anything come to mind there in terms of updates, major changes? I mean, are you happy with the progress that Safari's making?
I know, definitely. Considering that Safari up until a couple of years ago didn't do a WebRTC at all, it's all great. So, but yeah, no, they did a lot of effort in that direction. They improved a lot the stack. They finally added support for VP8 as well, which was great because I mean we've we all know what the great war between VP8 and H.264 has been to WebRTC. So knowing that now we have support for all of those codecs in all browsers is actually a very good thing. And I actually had the chance of spending some time with one of the Safari developers at one of the latest ITF hackathons, where we worked together on fixing some simulcast-related issues that they had in Safari, which was great. I think there's been a lot of progress there. So Edge moving to Chrome. Some have seen it as, let's say, one more step towards the, let's say, Chromium monoculture, which may be a bad thing. On the other side, it greatly simplifies things. It makes things much more stable, as you said. So I think it eventually was a good thing. So personally, I'm satisfied with how browsers are getting closer to the final target. We're not there yet, because we all know that WebRTC is not done yet, and there are still some differences in browsers and how they implement things, and simulcast was one of the, SBC is one of the others. So it's a good thing that we are going towards the target now.
Right. Maybe shifting a little bit outside of the browser and looking at native, and maybe James, you can tell us a little bit more about your domain. What's, I guess, how does the native experience compare to the web? You know, do we even need a native experience if the web and you do WebView and that's caught up? I mean, obviously you had some comments, you know, that Microsoft chose not to for a reason. Maybe you can elaborate a little bit more.
Yeah, definitely. And that's the kind of discussion that we have often at Microsoft. Do we really need a native stack? Can we just run everything in a web view? And my answer has been, we do have a need for a native stack. And I'll give you a few different examples. One is mixed reality apps, reasonably popular. Most people who build that stuff on a Microsoft platform are building it in Unity or UrhoSharp or Unreal, some sort of 3D engine, and they're probably rendering a bunch of complex models in that environment. And at the same time, they want to stand up a real-time feed between a remote party and somebody on one of those devices to enable communication. So in that kind of scenario, a web view just doesn't make a ton of sense, right? If you're probably writing your code in C++ or maybe C# if it's Microsoft specific. In there, you don't want the overhead of an additional garbage collector running in the web view, having to now also write JavaScript. So in my mind, if the only development model for getting at the browser stack is a web view, that's not a great solution. That said, I feel like WebRTC is a unique part of Chrome, in that it makes a lot of sense to use on its own, right? I can't think of any other, and the Edge team couldn't either, any other piece of Chrome that we would want to just lop off and make available by itself to apps. But WebRTC is a great example there. So, you know, people are building different experiences on native apps, at least from what I've seen, and I could talk through some of those if you want, or you know, that's kind of where I stand on the browser versus native discussion.
Okay. Well, maybe maybe Lorenzo, I'll ask you next the same question. I think I know personally I've asked for more native mobile support on Janus a few years ago. I'm not sure if you guys done much there, but what are your thoughts on the web versus native?
No, I do agree that native is actually a key factor, and I think it's been one of also the key factors in a wider adoption of WebRTC in the first place, because it was born as a technology to allow people to call each other via a browser, but then it exploded in something way beyond that. So now you can do WebRTC on a Raspberry Pi, you can do WebRTC on tiny devices, you can do telehealth and contact centers and whatever with WebRTC, which is amazing. And I think that this has been facilitated by the integration of a WebRTC stack also in not browsers. So think of gaming, streaming of video games, or playing video games via WebRTC as well. These are all things that are only possible because you have low-level stacks that are native that can actually do interesting things. Now GStreamer supports WebRTC. There are several stacks like Pion written in Go that can do WebRTC outside of a browser. These are all good things, and I think that we should actually foster these.
Jonathan, how about you at 5.9? Is there a native
we have
interface for agent? How do you deal with that?
Yeah, so we have a we support a browser plugin that actually installs a classic soft phone, but we also just have WebRTC support as well. It's a little easier for voice. A lot of the hairiness that's really bad gets in there for video. But in general, I think if you look across the industry, not just 5.9, there's still a lot of like native desktop apps doing real-time communication. Zoom, like still thick desktop app. WebEx still primarily thick desktop app. So especially for video.
Okay. Hey, Anthony, anything quick to add? You don't have to. If you,
I think there's a lot to do to make even ordering food work where you don't still need a native app. Like LinkedIn still needs to make a native app. So the voice stuff is even farther away because WebRTC in a web browser is pretty cool. We've actually pretty much gotten to that point now. We have something in the works to pull it off, but like it's only going to work if you're engaged with the page already. Like you can't call them on their phone through the web app because it's only working when you turn the page on and allow it to. So, right there you must have a native app. If you want to make the phone ring when somebody calls you, there's no other choice. And unlocking that for the web browser would be crazy security.
I mean, have you looked at
challenge
extensions and other things?
I
guess
there are push stuff, but like it's as you said, it's like scary to turn it on. So I think the web is just not a good metaphor actually for a persistent thing that always runs all the time. That's the core problem.
Yeah. Have any of you guys played around with progressive web apps at all? I guess particularly with real-time communications. No? Okay. We'll come back to that. When we go to the next topic, open source, Lorenzo, WebRTC started out as an open source project. It's obviously very popular in open source projects, but I guess how's it doing? What are some more popular projects out there today? And is open source keeping up with the market and all the changes we've been talking about in the browsers?
Yeah, sure. I definitely believe so. And as you said, WebRTC was born as open source, and I think open source was one of the key factors that actually led to the success of WebRTC because it allowed people to, no matter where they came from, big companies, small companies, university students, to play with the technology, mess with it, bring it forward, work on exciting stuff, and work on new applications, use cases that nobody even thought about when WebRTC was first conceived, and that was great. And I think open source contributed a lot there also in terms of the software that people started writing to support WebRTC applications. So, of course, Janus is an example of that, but there are a ton of other applications. FreeSwitch is another. Asterisk adopted WebRTC soon and made all things that made it easier for telephony-based applications to start using WebRTC as a vehicle for accessing all of that. Jitsi, MediaSoup, all of these frameworks made it really easy to start using WebRTC in production for work, for things that were much more than just tinkering a bit with the technology. And I think the open source community is still doing a lot in that regard. So, and I think it will still play a very important factor for the future as well. So I'm thinking, for instance, about the future of WebRTC, like Quick, KV1, and so on. I think that I believe that open source will play an important factor there as well in moving things forward.
All right. Any other panelists want to comment on open source?
I will. I would know a little bit about open source.
Just a little bit, yeah.
Something like this has to be open source, or it won't go anywhere. Like you were talking earlier about VXML. Like, sure, Cisco made a couple bucks off of it, but it never got popular because they started out the first VXML. You had to buy the composer to make the XML. Like, who's going to do that? Like, it's a new cool thing. I promise you, it's really great, but you have to buy it. And you can't use it unless you also buy the server and the component. And like, so you can start a good business. You can probably find a market and sell it to them. But if you want the entire planet to adopt it, like you have to make it available. Like SIP would never exist if it was something you had to buy. And some of these things just have no choice. And open source is really kind of where you bootstrap stuff, because people are willing to. You get so much more of a rapid feedback loop than you did. Like, if you just made your code, the version 1, and then waited for someone to buy it, it'd take you 5 years by the time that someone found the first bug, like someone else is already beating you. So core technology like that actually accelerates from open source, and there's less of a burden on open source because it's not, no one expects it to be a product. It's like you have this ability to kind of play around with ideas and experiment on people, like Webrtc does to us every morning. We start Chrome, it's like roulette. You know, is it going to work today? You know, that you can get away with some of that stuff. So that's really like a really good place. It's like a lab environment to figure out what you really want to do. And there's a place for business to evolve beyond that. And that's kind of like some of these low-level protocols and things like that that are just useful. You need the entire world to agree that it's a good idea first, or you have no choice. Like, you're not going to succeed at getting any traction out of it until everyone adopts it. And they won't adopt it unless they can have easy access to evaluating it.
Okay. Jonathan, I'm not exactly sure what your Webrtc stacks looks like, or if you can share those details. But maybe you can comment a little bit, like where does open source come into play, especially on the Webrtc side of things.
Yeah, I mean, I think these folks have said it well. I would sort of say that yes, but they are products too. So I mean, we obviously have lots of people out there selling products built on top of open source, as we are. So I mean, 5.9, we use FreeSwitch. It runs our core voice network. That's the foundation of our platform, and it's open source. We use Camilio, and so it enables people to build products and not have to, buy them or spend a lot of money, or at least to get started. You usually want to buy a support contract at some point, right? But I mean, but you can get started much easier. So it's an enabler of innovation.
So I guess you definitely haven't been scared off by open source and having to figure out something, or not necessarily having a predefined service contract with everything that you use.
It depends, to be honest. I mean, like it's sort of it's a core versus context thing, right? If it's a piece of software that you want to use to build a SaaS service and it's core to your business, and if it fails, everything's in big trouble and whatever, then maybe and it's hard to replace, then maybe you do want to go and get yourself a support contract. I mean, that's just common sense.
Okay. Next, I guess I'd like to talk a little bit about security, because I guess there's been a lot of security, privacy type issues that come up, and particularly in the last year. I mean, WhatsApp had some RTCP issues. There was Google's Project Zero uncovered some issues with fuzzing with Webrtc. And just recently, Zoom had some major, issues with privacy concerns, the way they're accessing camera. That's all stuff that potentially impacts Webrtc. So maybe talk a little bit. I'm very curious how does Microsoft look at some of these security issues when it comes to fuzzing and privacy, and how does Microsoft deal with that as a larger vendor?
I was hoping you wouldn't call on me, Chad. We keep track of that stuff internally based on which products are using for Webrtc in particular. In my work, we kind of rely on Google as being the baseline. Like, we have the same security implications there. So as far as Edge goes, I'm sure they have a whole nother test system that they could talk through. But for UWP, we count on being a Chrome equivalent for a certain milestone, and then paying attention to any notices that come out after that. Honestly, knock on wood, we haven't had too many problems yet. So I think for a native client, when you've got the opportunity to freeze your stack at a certain version of Chrome, that version's pretty good because it's been around. It helps minimize those kind of problems.
Lorenzo, on Webrtc Hacks, originally we found some fuzzing issues, and then you came back, and maybe you could summarize for the audience what that issue was, how you addressed it, and I guess your learnings from that exercise.
Yeah, and as you said, the Project Zero started finding a lot of issues in several different pieces of software, including the Webrtc stack, which were soon fixed by Google itself. But then Philip Punk tinkered a bit with Janus itself to see if the open source, or let's say the available existing Webrtc implementations could suffer from the same problem as well. And surprise, surprise, they did. So he managed to crash Janus pretty much immediately with some RTC packets and so on. And this basically triggered us into checking how we could fix things. So we played a lot with libfuzzer, and eventually we basically worked a lot on integrating libfuzzer as part of our build process. So basically now to identify all the potential issues in RTCP, RTP, a bit of SDP as well. And this actually strengthened our code base a lot. And we shared all of these details on the WebRTC Hacks blog post. So if you're interested in it, you can find all of these details that actually one of my colleagues, Alessandro Toppi, worked on. He writes a very detailed tutorial about all of the steps he did, everything that he learned, exactly what he did, how you can try and replicate the same things. So if you have an RTC stack of any sort that you want to strengthen, by any means, go there, have a look at what you need to do, because actually when you integrate fuzzing, you realize that why wasn't I already doing this in the first place? It's actually a very integral component of our development now, and it's actually very important for security.
Other panelists want to comment at all, I guess, on how you think about security and maybe some of the specific issues that happened in the last year or so?
Maybe tying a full circle to when we were talking about what's new in the browser and that kind of thing. We saw that in the world, people had noticed strange, you go to like CNN and they'll do get user media and a peer connection just to map your network IPs and stuff. So now, thanks to that, we have this MDNS thing coming down the pipe, which I forgot to mention before, which is going to break everything also. So everybody that makes their own stack is going to have to go and implement that now, or like overnight, everything will break. So there's the kinds of like, that's one security thing that probably is a good one to fix, because that kind of keeps people nervous. Like you don't want like web pages poking at your private IPs, and so though I dread having to deal with that, like it was probably a good idea.
All right, maybe our next topic is around, actually keep it with you, Anthony, around scalability, deployment challenges. So you've been doing this for now. I guess, what have you learned in the last year or so? I guess deployment scale, is it getting easier to do? Is there anything unique, for Webrtc specific that you had to do?
Yes. One of the things that was important was we have to do a little bit of patching on our VPX codec, because it's designed by scientists whose goal it is to have the least amount of time to encode Big Buck Bunny into a VP8 file. That's really what drives all the development. So, well, you can write this one command line app that can like do that faster. When you do something like a server where you say have like 100 calls at once on the same machine, you might need 100 copies of the codec. And that codec, each one of them can't contend to try and use up the entire CPU. So that's one of the things we ran into. We ended up having to put in our own, we had to put some kind of yield into there. Minor performance hit in the Big Buck Bunny thing, but it like allows us to scale more channels, because otherwise you have like one taking all the resources and the rest are starving. So yeah, the threading model on the codecs is still a little far behind. Another reason why I hope VP9 gets better. It's still way too CPU hungry, but at least they have a little bit more thought about threading, because you can do multi-threaded encoding, which speeds things up, because you can split it into 4 and build quadrants of the video image at the same time. But then like it's kind of the way that those threads are managed is still sort of basic. Like it's not well thought out. It's just kind of threw it in there to add it. I think that's going to take a little more work still. And concurrency is the key to VP9, I think, because it's still like you put it on one core. You can basically take a call, go in the browser, and we have like an echo app in FreeSwitch where all we do is send you right back the same thing you sent. And that maxes out my computer's processor, just like sending myself the VP9 that the browser generated. So that's something we have to try and figure out still, and that's not just on us. I guess the whole world has to work on that one. So, but we have our eye on that, because VP9 is really better. In this NetSVC or NetVC, that's coming.
AV1,
Yeah. I was gonna say, why don't we, since it's coming up a lot, I was saying, why don't we skip a little bit, and I'll let Jonathan, maybe you can help explain to the audience the evolution of VP8, VP9, H264, H265, and now AV1, Open Media Alliance stuff. If you could just kind of set the framework so everyone understands the media codec landscape and what's going on there, and then we can talk about what that means for WebRTC.
Yeah, so it's a mess, really. I mean, codecs have always been a mess because of patents, really, more or less. So, we had the prior gen wars, which we heard about, which were VP8 versus H.264, and the good news is we figured out a way for both to win, more or less. So both are supported. H.264 widespread deployment in the net in general. So now it's about what's the next generation codec, and that's where Google put forth their VP9, but it was again Google proprietary, Google controlled, and so some standards activity was started to sort of make that an official standard with other contributions, so it wasn't wholly controlled by Google. And by the way, at the same time, try and as much as possible steer clear of the patent mess. The official next-gen codec that succeeds H.264 is this thing called H.265. Very easy to remember. And 264 was the successor of, anyone want to guess? 263. What was the one before that? It was 261, actually. So I don't know what, I actually don't know what happened to 2. But anyway, so I'm sure there's a spec, just no one liked it, I guess. So 265 is the successor, and if you thought H.264 had patent problems, then H.265 will blow your mind. It is near unimplementable, undeployable, and unusable because everyone got greedy, and there's tons of patent pools and submarines and sharks and whatever. So it's a case where the technology's patent pool probably will kill the technology before it ever gets widespread adoption. I think we'll see it in cable boxes where those guys don't really care, but on the internet, I don't think it'll ever go anywhere. So AV1 is sort of the standards-based version of VP9, taking other input. So when I was at Cisco, we had codec guys, and they contributed some stuff, and Google contributed, and a bunch of people contributed. And this new codec called AV1 was produced by this thing called the Open Media Alliance, or OME, and it's getting close. So they had spec freeze, and there's an open source reference codec, which of course runs at a snail's pace. You get better compression efficiency by utilizing the CPU more heavily. Like it's that simple. Like the more computation you can do, the better you can compress. So it's always takes some time. There is not yet, in general, there's not, like the reference encoder will not encode in real time. When I was at Cisco, my team, we spent 2 years basically taking that reference implementation and making our own that ran it real time. It finally just shipped after I even left. WebEx, Cisco announced that they are now using, they had a demo or something of AV1 running in real time. So it's not quite ready yet, but it's twice as good for the same bandwidth, or half the bandwidth for the same quality, and that's always good. Video's still a big issue at scale. So I think it'll likely make its way into WebRTC, but we got a little ways to go before it's sort of real time enough to do that. So that's the landscape.
Any timelines or estimates on at least your own personal guess on when it would be available?
Just based on how long it took us to build a real time version of the reference codec at 2 years. I don't know who else had started working on it, but you guys are working on it.
No, I just wanted to add that about the open source implementation, actually there are some news in that respect, because Cosmos Software in particular has started tinkering with it a bit, and now the latest ITF hackathon, they've also discussed that they managed to get a basic code working basically in real time as well. I don't know how much it compares to the one that Cisco advertised, but they plan to make it available soon for more widespread testing with other open source implementations. So that's good news there.
The trick, I should be clear, the trick isn't getting it to run in real time. The trick is running it real time without too much loss in compression efficiency. So that's the hard part, and you do sacrifice some.
Yeah. Well, I mean, Anthony, you've talked a lot about VP9. Have you started thinking about AV1? If AV1's right around the corner, does VP9 matter so much? I'm not saying it is.
I have both of them. No, they're both just in the fantasy category still. I just try it every once in a while. We actually have a VP9 module, but you have too many calls on it, the whole server dies, and so it's not really that great of a choice. VP8 really is just all you have to work with if you want it to work everywhere at this point. It's kind of like the ULA video codecs, so I'm sure we'll figure out ways to make it a lot cooler over the years, but I have my eye on it. I just check every once in a while, and still not ready. So I'm sure one day it'll appear in my lap, and then I'll.
Yeah, I'd say a couple of years before it's ready for real time. There's plenty of juice still to squeeze out of the existing stuff, even 264, which I know the open source people don't like to talk about 264, but it's everywhere, right? Every cat video is 264, just saying. But 264 has this profile concept that's somewhat dreaded because it makes for interoperability problems, but like you can throw more processing power at 264 and increase its efficiency as well. So there's work still there to even sort of get more juice out of the current gen.
I like it. The good thing about 264 is you can just jump in anywhere. Like BP8 is a lot harder to lock onto a stream, so there's some well thought out reasons why it's designed the way it is.
Yeah. James, do you have any? What do you do inside UWP? Preferred codecs and future codec support?
Yeah, definitely. For UWP right now, we do prefer H.264. That's because it's available anywhere that Windows 10 is available. It's a built-in, paid-for codec that comes with every version of Windows almost. So we prefer that today. VP8 and VP9 we found sometimes have better motion artifacting. So if you're taking a video stream from a camera that's not fixed and you're walking around with it, often VP8 and VP9 just look better than H.264. And for AV1, there are people at Microsoft working to optimize the encoder and decoder. So that's we are a member of the Alliance for Open Media. So definitely looking forward to seeing that and to testing Cosmo's work. I think they used the VP9 packetization against AV1 to get that to run for RTP, right? So I'm interested to start playing with that. You know, at the Agora.io's conference, I forget the name of the researcher, but she showed that they had working real-time AV1 video, and it was a proprietary solution, so they didn't share it. But I'm very interested to see how that's done. I think it may not be 3 years before it's possible, but certainly until it's wide scale.
Yeah, I guess it's a whole another step getting it to work in the lab and putting it in a browser for billions of people too. But,
exactly.
Yeah.
Yep.
Another bonus for 264 is that it's implemented in hardware everywhere.
Yeah.
So you have like, if you run it on a device that supports it, it just can decode it with the hardware. It's already there, which is nice. We've been playing around with that also.
Yeah, I guess we never really saw VP8 hardware acceleration take off.
That's what happens when you have a proprietary solution. So.
Yeah. Well, maybe standing, keeping on the standards type topic, there has been some pretty, significant updates or changes coming, or that will have impact on real-time communications, like Quick, Internet 3, and even in the browser, things like WebAssembly. Maybe it'll start with Lorenzo. Can you walk us through, I guess, what is Quick? What does that mean for Webrtc? And then maybe as a second topic, WebAssembly.
Yeah, I'll briefly describe what's happening, and then I'll go a bit on a rant because I'm excited about that stuff, but I'm also a bit concerned about some things that are happening there. So basically, Quick is the new protocol that the whole ITF is focusing a lot of effort on, which will be the basis for HTTP3, which is also the basis for RIP, as we found out by Jonathan today. And the idea is that since there are several use cases that warrant, let's say, a bit of a refactoring in WebRTC, so something that is more organic and for audio, video, and data to go and share basically a common protocol. And Quick has been the main choice for that, mostly because it's actually being actively worked on in the ITF for several use cases, actually. So it's not there yet, so it still needs some work in order to be done, but it will actually be the foundation. It's a UDP-based protocol that has congestion control, flow control, everything that typically TCP has, but much more efficiently using UDP instead, and much more flexible because it will allow you to do a lot of media delivery streams and so on.
And that's no head-of-line blocking across streams, the most important thing that enables real-time.
Exactly. There are still some issues. I mean, there have been some analysis, for instance, on whether RTP on Quick would work well or not. Some issues there in general. But in general, the idea will be probably that Quick will be the transport protocol for everything, and then you sending the media on top of that will be up to you. So how you do packetization, how you fragment the messages if needed, and so on will be up to you in general. And for what concerns WebAssembly, that's basically the other flip of the coin. So once we have a protocol that is flexible enough to do everything, whatever we want, it means that we cannot rely on the browser doing everything for us. It means that it will be up to us to take care of the encoding process, the decoding process. Capturing the video is something that we do already with Get User Media, but it will be up to us to encode the stream, packetize it, take care of whatever we actually need in order to, I don't know, retransmit packets, implement forwarder correction, and all of things like this. And the only way
up to you or optionally up to you, I guess.
That's one of the big questions and one of the concerns that I have in general, because right now the only way to do that is taking advantage of a technology like WebAssembly, because if you need to do everything, all of this stuff in JavaScript, of course you cannot do it in JavaScript. You cannot do a live VP8 encoding or H.264 encoding in JavaScript, or let's say you can, but it's a bit
I think
problematic.
maybe we should take a step back. Someone, it doesn't necessarily have to be you, Lorenzo. We probably should explain what WebAssembly is, since not everyone here is a web developer.
It's basically I'm not much into I don't know very much about WebAssembly, but it's, let's say, a much more efficient way of having pretty much native code that actually runs into the JavaScript virtual machine instead. And so typically you write actually native code and then you convert it to WebAssembly, which can be considered like some compiled code that actually runs inside a worker in JavaScript. So typically much more efficient and so on. And they're actually working a lot to make it very, very efficient so that the concept of actually working in JavaScript shouldn't worry people anymore. But it's actually a quite complex
and people have actually used this though to run codecs like
I think somebody converted the whole VLC stuff in WebAssembly or something.
Yeah.
So I'll say a few things. First of all, people have been making audio and video codecs and encoders and decoders in JavaScript for some time, I'm aware of several that are doing this, and it's sort of interesting. I'm a big fan of the approach, and in a lot of ways, it's sort of a regret of mine that WebRTC wasn't able to use technologies like this because they just weren't quite ready at the time. And if you look at how long WebRTC has taken to roll out and how many interoperability problems we had, it's because we have to standardize so many different protocols and layers and whatever. And in many ways, that's sort of anathema to the whole idea of the web. Web didn't, if you wanted to build a new app on the web, you could. You didn't have to go to the IETF to figure out how to make LinkedIn. Once we had HTML and HTTP for that type of application, it was enough. We didn't need to go to standards every time we needed a new feature. We don't have that still with WebRTC. Every time we want video conferencing, to go back to the IETF and figure out how to shove simulcast video into SDP, which is, trust me, it's a horror, right? So, in hindsight, I thought, I think the entire WebRTC industry would have gone tons faster if that stuff could have been solved with open source instead of standards. Meaning, if the browser could implement very low-level primitives with safety, and a bunch of people implemented that stuff, and you could just download in the browser. And then everyone, if you wanted a new feature, if I was a video conferencing company like Miyako, and I wanted my special sauce in the thing, you just go add it, and you're done. You don't need to wait for the IETF. Wait for IETF is not a fast path, and the less standards you have to have, the better we are. So that's my perspective.
Yeah, I would just want to add a couple of quick notes on this. Mainly my concerns, I'm very excited about all of this as well, but I have a couple of concerns. Mostly, one is that WebRTC is not ready. So we are already moving a lot in a new direction while there are still issues in all the browsers and so on. We use WebRTC every day, but there are still some problems that need to be solved from a specification perspective. And I realize standards are slow, but unfortunately now we have this thing that needs to finish. And actually, I do worry about interoperability once we have this flexibility. It will be very exciting, but it also means that, for instance, I won't be able to just take GStreamer and stream to Janus or talk to FreeSwitch easily, because maybe we will do our own thing or we will packetize stuff our own way. FreeSwitch will do it another way. It will mean adding tons of different layers anytime you want to actually interact with other components. So it's perfect to build your own island, your own web application and stuff like this, but interoperability is actually something that we might benefit from. So it's something that, in principle, we might do by just recreating some sort of pseudo RTP stuff on top of Quick and have people adhere to that when possible, or otherwise do your own thing. But it's still something that concerns me a bit. And the complexity of WebAssembly is the last thing that worries me a bit, mostly because I fear that it may end up being more complex than it was in the past for open source applications to be able to contribute to that. So larger companies can just shove 200 people to work on that stuff and they'll get it done. It might be much harder for us to actually take care of encoding and decoding stuff, implementing an encoder or using existing ones there. But apart from that, I'm excited about the prospect. I look forward to see where we're going, and hopefully my fears will go away.
All right. I do want to make sure we leave some time for audience questions. Let's go through my last one real quick. Machine learning is pretty big in computer science. What does machine learning mean for WebRTC? Is it finding its way inside the Webrtc stack itself at all? And what outside of the stack for Webrtc use cases, where does it come into play? Maybe let's start with you, Jonathan.
Yeah, so it's interesting. There's some work, mostly more research work, on like trying to do things like image segmentation in the browser, and it's possible to do these things today with the current APIs, and so you can do background removal and things like that, and it's kind of interesting. It's not. I wouldn't say there's anything big happening on that side, but I think there's a much bigger, interesting wave coming around, and it's not specific to WebRTC, but for telecommunications as a whole. And the way I talk about that is this: that if you think about all of us, the entire industry, who've been working on telecommunications for the last 50 years, has been to try and basically get audio and video bits from here to there, and just move them, not like maybe encode them and decode them, but not explore the semantic content or meaning of it. And that's all we've been doing. That's not true for other forms of information on the internet. So documents, web pages, we have years of indexing and searching and sorting and understanding, and Google is like scarily good and all these kind of things because we've been processing the content. We haven't done that for voice or video. Now we're finally at the point where speech recognition quality, because of deep neural networks, is getting good enough. The economics of it are getting good enough. Cloud platforms are allowing broadly available compute to be good enough. And so I think the next generation of phone calls and meetings and contact center, that's why I took my job, are all about basically bringing AI into voice and video so that we're able to sort of analyze the semantic content of a conversation. And I give an example, like simple examples, like if you're in a meeting and I'm talking to Anthony in a meeting and I say, "Hey Anthony, I'll give you a call next week, all right?" He's like, "Yeah, sure." We just say that kind of stuff all the time. Wouldn't it be great if my assistant, who was like, listening on the call, heard me say that, noted it, put it in my calendar to call Anthony next week? Stupid little example, right? We do this today with things like Siri. We have to talk to it. The next phase is it's in all of our conversations, adding value, and I think this will be the next wave of telephony, meetings, and contact center.
Thanks. James, you've talked. I mean, I've seen you do HoloLens demos and things like that. Maybe you could talk a little, where do you see AI, machine learning, some of those technologies intersecting with real-time communications with some of the stuff you're working on?
Yeah, definitely. So at Microsoft, there's a research project that runs in the cloud, uses our native stack, and it is able to accept peer connections from any number of clients. And it then it receives only, so it's a one-way stream, and it runs ML against the video and against the audio that are coming in from those peers to be able to do things like sentiment analysis, like the person in that video is happy, unhappy, whatever. And it works. Like this is something that we can do today, but we had to make several modifications to the WebRTC stack to be able to get at that raw data. It reminds me of Justin's demo at Cranky Geek, where he was chewing potato chips and able to filter that out. But he did that in WebAssembly, right? So that makes a lot of sense to me in the browser. So the question is, what is that? What is the analog for a native client there? How do we give them access to that data so that they can run these scenarios? So interested to see which way that goes.
All right. We have a couple minutes, unless there's any quick comments. Oh, maybe we'll cut to audience questions. Travis, are you around? Maybe you can help hold the mic for people. No, Travis? Okay, maybe I'll run around and hold the mic for people.
Or we can repeat the question.
Yeah, audience questions. So let me just repeat the question. So the question was basically, is voice nailed? We've talked a lot about video. Is voice, easy, standardized, or any concerns there?
There's actually one interesting thing happening in the audio space. I'm not sure it's actually that interesting to this audience, but in general, you all know, you're all familiar with the Opus codec and how it actually greatly improved audio on the internet because it was conceived with the internet in mind. But it so far has been limited to a stereo approach. Now they're actually working on multi-channel Opus instead. This is probably going to be worked on at the ITF soon, which will allow you to, for instance, do 6.1 Opus streams over WebRTC, which will be great, for instance, for broadcasting, because large-scale broadcasting is another very interesting use case that is happening right now in WebRTC.
So there is, I think we're good for a while. I would consider that a tweak, but there is definitely research happening on the next wave of even audio codecs by basically using machine learning and to, in essence, sort of predict and transmit model parameters and whatever that are totally different ways of implementing codecs that achieve even better, like significant, not just like 10% is what I'm hearing, like significant gains. So, but nothing soon.
Other questions?
Have you guys come across like client networks? They're all implemented differently, and in businesses they hate UDP, so run into a lot of issues with that. But have you ever thought of like the WebAssembly stuff as fallbacks rather than go to, or have you ever actually gone into it yourselves and tried to implement a solution with it? Like WebRTC without ICE, basically, in SDPs.
Yeah, so I think the question was, there's a lot of UDP issues, and has anyone here tried to do something like implement WebRTC without ICE using WebAssembly?
I think, yeah, only Zoom probably has done something like that. So.
The only thing that comes to mind for me is client server quick. So there is a spec for that. You don't need ICE because you have a known endpoint. So that's a potential future scenario, but no, not with WebRTC.
Other questions? I'll also say if there's questions for the panelists to the other panelists.
Actually, I may have a kind of a weird question after Jonathan's presentation today. So do you see any valid use case for having browsers be RIP clients? Because considering the HTTP3 would be used there.
Yeah, actually, yeah. I mean, it wasn't the original purpose, but Justin Webrtc was quite adamant that he wants to solve that problem with RIP as well. So I think it could very well be, as you identified it. And Anthony said, like, we skipped the signaling protocol. It's because it gets back to what I said, like, solve it with open source, not standards. So just implement a library or whatever. Anyone can do what they want. So yeah, I think there is potential interest in doing that kind of thing.
Other audience questions? I think the question was, does Webrtc 1.0... free switch support unified plan?
Ish. The unified plan doesn't even support unified plan, so we kind of do. Like, we play along as much as everybody else does to try and make sure that the call still sets up. But there's, like, if you took the spec and looked at it, not as much. But neither does anybody else, so there's not. there's a lot to do on that one still.
Yeah, what are your, the question, does it support Google's unified plan? I was going to ask, actually, what browsers do you use as a reference?
Well, we use them all a little bit. We're pretty Chrome heavy since that's usually the source of it. You know, we know Firefox and everybody else kind of uses portions of the code. We have, they're always in a different place though, regardless. Like Firefox was already full in on Unified Plan, way ahead of everybody, and then Chrome's the one that wanted it to be there, but then they didn't turn it on, and then they did, and then like one day you either had to force it on or not force it on. So we try and just accept whatever is thrown at us, so that the call sets up, and we're still working on Unified Plan responses, so that you could maybe have more than one video stream in the answer, but that's still in our lab. It's going to be a while.
Yeah. I have so many more questions, but we don't have time for them. So maybe we'll just close things out. If you could just provide a quick thought and make you think on your feet a little bit. For someone working with Webrtc or about to work on Webrtc, what piece of advice would you have for them? Maybe start with Lorenzo and work towards Jonathan.
So if you want to start working with Webrtc, what do you need to be worried about? So, yeah, be prepared for a lot of headaches, but no, just kidding apart. So you, especially right now, Webrtc is a mix of web technologies and voice over IP technologies. So if you're just familiar with one, be prepared to study a lot to make sure that you get familiar with the other part soon, because you don't want to be the web developer that doesn't know what SDP is and the problems that it can cause you.
Okay, so learn SDP, even though it sucks.
Yeah, no, exactly. For the time being, yeah, that's we are pretty much stuck with it. Nobody loves it, nobody likes it.
We
but
killed it in RIP. We
yeah.
just had enough. We tried at ITF like 3 times to kill that thing.
Thanks for that.
Couldn't do it.
Yeah, well, actually, speaking of killing, SDP, Microsoft had an early attempt with CU Webrtc and ORTC efforts, but you never did that.
Right. We do.
It's like a zombie.
Yeah.
You kill it and it just comes back.
Yeah, exactly. My advice, I think, if you're trying to build a product, be prepared to spend. You heard many times today how things break all the time. Things don't work as advertised, so be prepared to spend as much time testing as you do building it, or more.
Okay. Anthony?
Well, I would say start with something. Find some things that have already been well established and try and learn your way through that first. There's lots of examples out there just for learn the mechanics. Most of those are pretty close to being right. We have shim layers and stuff that at least, no matter what, makes that spec work. So it's actually a pretty good time to start just learning those things better than it used to be. They used to have all these experimental parameters and stuff that are all kind of hashed out now. Like I had to figure out how to do frame rate and stuff like 5 different ways along the time, because even though they would like prefix it with experimental, and like Firefox likes to put Moz in front of their parameters, but some of them still snuck through, and they're like, oh wait, we forgot, like screen share, for instance. I'd say like this is a good time to actually read the spec from, look at the WC3 thing, because it almost works now.
All right, read the spec. Jonathan?
Well, I mean, unless you're building your own meeting service or voice, most people don't need to really know this stuff at all. So, I mean, don't reinvent the wheel. If you just want to add a click to call to your website, you should be even reading the Webrtc spec. Go buy something. Or take some open source.
Awesome. All right, thank you all.
Thank you.
Yeah.
All right, wonderful. Big round of applause for our Webrtc roundtable.